Good morning, everyone, and welcome to another day of my discussion in science. I am Mom Princess, and I hope that you are ready to listen. So let us start. Today, we're going to learn everything that you need to know about light energy and electromagnetic spectrum. And it's gonna be awesome, of course, because we're going to discuss topics like refraction, waves, and electromagnetic radiation. We're going to learn it all in just the next few minutes. So, are you ready for this? Yes, I am. So, let us have fun with light energy. Light energy is a form of energy which helps us to see objects. Light travels in waves, and when light falls in an object, it reflects the light. When the reflected light reaches our eyes, then that's the time that we can see the objects. Light travels on a straight line for about 186,000 miles per second. So that's awesome fast. It is faster than the speed of sound. Light is reflected, so we can see objects. Light waves also helps in the formation of shadows, images, using mirrors and lenses. The bending of light by the different mediums, twinkling of stars, and formation of shadows are also because of the light energy. Light and matter. Light waves can pass through the objects. So that's the reason why light can also be transmitted. When the light hits an object, transmission of light occurs. It is because the material or the object is transparent. For the transmission of the light in the different objects, we have transparent, translucent, and opaque. For transparent material, it allows all the light to pass through. For the translucent material, it allows some light to pass through. And for an opaque material, it does not allow the light to pass through. For transparent, an example of this is a glass of water or a clear glass of water. For translucent, curtain. And for an opaque material, our human body. Human body is an example of opaque material because it blocks the light. And when the light is being blocked, it forms shadow. Only to a material that is called opaque forms shadow. Light can also be absorbed by all the objects like in this diagram. An example of that are the white lights coming from the sun hitting the plants, particularly the leaves. Most of its waves are absorbed by the leaves except the green, and therefore it is reflected back in our eyes. And that's why a leaf looks green. That's awesome, right? The waves can be scattered off the object. So white light directly from the sun hitting the objects. We can see the objects like the sun's light hitting the cloud. The cloud droplets scatter all the wavelengths of visible light, creating the appearance of white clouds. But the sun's light also hits the atmosphere. So those light waves are scattered, and usually those waves are shorter waves of blue. And that's why our sky is color blue. Reflection. We see the moon in our atmosphere because it reflects the sun's light. It takes 1 second for light waves to reflect off the moon to reach the earth. The reflection of light happens when light falls on a shiny surface like mirror, and that's the time that the light is bouncing back. We call this as the reflection of light. Like in this diagram below, you can see that as you look at the mirror, you can see your image because the light is being reflected on the mirror. And even this hot balloon having its own image in a clear, shiny water. For the reflection of light in a color like this, under the light, this bag only reflects the red light. That's why it appears to be the color red in our eyes. But it absorbs all the colors except red. Next question. Why is black shirt hotter than a white shirt in the summer? It is because a white shirt reflects all the wavelengths of light. And for the black shirt, it absorbs all the wavelengths of light. The black shirts absorb all the energy, therefore it turns into heat. That's why during summer, we should wear shirts that are in a light shade of color, like white shirt, yellow shirt, or light green shirt. But if it is cold, you can wear shirts that are in a dark color, like black color, red, or orange. Next, we have the refraction of light. It happens when light travels from one medium like air to another medium like water. So that's the reason why light gets bent. We call this as the refraction of light. Take a look at the pencil in a glass of water. It looks bent, but it is not, because the light is being refracted. Now, let us talk about electromagnetic spectrum, since you are aware of what is light energy. Different frequencies of electromagnetic waves correspond to different kinds of light. Visible light of different wavelengths actually produces different colors. These different colors pertain to the different frequencies. Those frequencies that are greater than a visible light are the ultraviolet light, gamma rays, and X-ray. For those frequencies that are lesser than the visible light, these are the infrared, microwave, and radio. All of these phenomena is collectively called electromagnetic radiation and can be found in electromagnetic spectrum. Here we can see all the wavelengths and frequencies ranging from the radio waves to the gamma waves. And we have found some technological use of this in our modern society. So even though they may seem dramatically different, like some requiring things like the use of antennas or any manipulative equipment, do not forget that when wavelength decreases, frequency increases, energy increases. So when wavelength decreases, frequency increases, and energy increases. But all of them are fundamentally the same example of the phenomenon that you can see in your eyes. These are all examples of the same phenomenon. All electromagnetic radiation moves at the speed of light of about 300 million meters per second in a vacuum. This is actually the fastest speed limit in the universe. This is actually fast enough to get from here to moon in about a second, since we know that all waves move at a speed equal to the product of the wavelength and frequency. So therefore, it will be equal to the speed of light for any type of electromagnetic radiation. So here is the equation for this, wherein C pertains to the speed of light. So we are done. Let us have a summary of our discussion. Light is a form of energy which helps us to see objects. Light travels in a straight line for about 186,000 miles per second. Light can be transmitted, absorbed, and scattered. Light can pass in a material like transparent, translucent, and opaque. And do not forget, for electromagnetic spectrum and radiation, frequency is directly proportional to energy and inversely proportional to wavelength, meaning as the frequency increases, energy increases, but wavelength decreases, and vice versa. So for now, let us check your understanding. Let us have question number 1. Number 1, it is the bending of light. Number 2, some light pass through this material like curtain. Number 3, it is the value of the speed of light. Number 4, shadow is formed when light is being blocked in this material. And number 5, it is the bouncing back of light. So let us check your answers. Number 1, refraction. Number 2, translucent. 3, 300 million meter per second in a vacuum. Number 4, opaque. And number 5, reflection. So for those who got it correctly, very good. So this is the end of my discussion. Thank you everyone for listening. Kindly subscribe to my channel, Mom PM is the key, and do not forget, click the bell button to keep you updated. Goodbye!